Welcome back, my friends. Let's look at some more radicals, some irrationals. It says simplify by adding like terms where possible. Well, at first glance, they don't look very like, do they? Because they have all kinds of different square roots. And it looks like we're done. It looks like there's nothing we can do. Except that we can. We can actually re-express these. And this is where your factorization, now your prime factorization, is going to come in quite handy, I might add. So why don't we try this? 44, square root of 44. Well, 44 is 4 times 11. We can break this down into its factors. This will be 4 times 11. Well, that means it's square root of 4 times square root of 11, which is really 2 root 11. Nice, okay. Is that going to help? I don't know. Then why'd you do it? What else am I going to do? That's just how I think. I'm like, well, let me break it down as factors. Maybe something will happen that makes it nice. I really don't know if it's going to work or not, but just from experience, I know that's really the only thing to do. And because it's a thing I can do, it's the thing I should do. And that's just how I reason, and therefore I do it. Let's move on. Minus 5 root 176. 176, that's not a familiar number. I don't really know how that's going to break down, but I do know that it's even. In fact, I can see that it's actually divisible by 4 at the very least, possibly more. Why don't we just start with that? Let's divide this by 4, and don't forget we have a minus 5 in front here. We'll just kind of keep that there. 4, let's see, that's 44, isn't it? 4 times 44? Well, we already know how 44 breaks down. This is going to be 4 times 11. And so what this means is that if you take, let me change this color here. If you take just the green parts, what this means is that we have the square root of 4 times the square root of 4 times the square root of 11. Square root of 4 times the square root of 4 times the square root of 11. Well, square root of 4 and square root of 4 are both 2. So this is 2 times 2, which is 4 root 11. And let's not forget our negative 5. And I hope I can squeeze this in here. I hope you're not offended. And I hope that still makes sense to you. And we have that part. And now we move on to the next one. So we have a minus 3 here. Minus 3. And this part here, 45, is going to be 9 times 5. And what that basically means is square root of 9 times square root of 5. And square root of 9, we all know, is 3. So this is going to be minus 3 times 3 root 5. I'm trying to color coordinate it so you see where I got these from, right? This 3 comes from this 9. And that's just from the prime factorization of 45. And then we have plus 2 times 99. So we have a plus 2 here. And I'll just try to remember to put this down here. And then the 99, let's see here. I guess we could use the teal. 99 is 9 times 11. And we already know the square root of 9 is 3. So the square root of 9 times the square root of 11, which is really 3 root 11. And so we put that here, times 3 root 11. Teal's kind of hard to see, but I'm running out of colors, so it'll have to do. Unique colors, I should say. I'm aware, but it takes time. And then minus 20 is 4 times 5. And let's not forget the minus, because that could cause a problem. And this means root 4 times root 5, which means 2 root 5. And we are well on our way towards a more simplified solution. So we're going to combine like terms now. And the ones that are like, there's really only 2 different kinds here. We have the root 11s and the root 5s. They don't talk to each other. They're not like, I mean the 5 and the 11, that is. They're like within the 11s and within the 5s. But so we're going to have to split it into those two groups. So let's underline or group together all the 11s. And let's see if we can combine these in an organized way. So we have 2 root 11. And this right here is minus 20 root 11. And then we have this right here is 6 root 11. So plus 6 root, this one right here. This is 6 root 11. Yes, I skipped the other one because I'm going to group them together with each other. And so this will be the minus 9 root 5 minus 2 root 5. And so now they're like with like. And so what we get, if we add the root 11s together, we have 2 minus 20 plus 6. So that's basically 8 minus 20, which is negative 12 root 11. And then the red ones, minus 9 minus 2 is minus 11 root 5. And unless there's an error I didn't notice, that's it. So these right here are our answer. This is the fully simplified version of that given problem. And now let's do one more. Yes, question.
How did you get number 6 right there? 6 square root of 11.
6 root 11?
Yeah.
Good question. So I have it marked, but
You said you skipped something.
no, I didn't skip that one. It's this one right here. Darn it, I didn't want teal. Let's go with black. It's this right here. Unnamed student who's a minor whose name I can't say.
So you just shifted to left.
Okay. So that's how I got the 6, right? Because 2 times 3 is 6. So that's 6 root 11.
Okay, I didn't know.
Yeah. All right. No problem. Next one. We're going to look at this one right here. We're going to rationalize the denominator. What do you mean rationalize the denominator? Well, did you know you're not allowed to have square roots in the denominator? They're irrational. And we need to make them rational, gosh darn it. So we can't be having irrationals. We can't, well, we just can't have the square roots. And, you know, in the course of my daily math, as I'm going, I may find myself with some square roots in the denominator. I don't bat an eye. You know, when I'm home alone and I'm doing math, no one's around, no one's looking. I can do that. But if I'm going to submit my final answer, you better believe it better not have square roots in the denominator. So we got to fix that. But how do we do this? Well, earlier in the other video, we talked about the difference of squares. And the difference of squares is a great way to make these radicals not be radical. What I mean is that if we multiply by the conjugate, so in this case, root 3 minus root 2, if you were to multiply these denominators, you would get the difference of squares. You'd get 3 minus 2, and that would be lovely. But we can't just multiply the denominator. We have to do it to both numerator and denominator so that this remains 1. And that makes it legal for us to multiply. And before I even do the numerator, let's actually look at the denominator. Do you see that this is, I'll do it all the way out, root 3 squared minus root 2 squared? Do you see that? Maybe not. So let me show you again. If you have a plus b times a minus b, that's a squared minus b squared. And in this case, a is really just root 3, and b is really just root 2. And so my a and b get squared, and they have the difference of them, and that's what I get. And again, before I even finish the numerator, I'm going to do something crazy unorthodox here and just finish the denominator. This is going to be 3 minus 2. And that's going to be a denominator of 1. Which means it's totally going to go away, which is nice. And that was the whole point. Well, it could have been a different number, but the whole point of it was to not have a square root in the denominator. And we managed that. So now let's look at the numerator and make sure that we, make sure it's all nice and stuff. And I don't like it because there's 3 terms, and that does make things a little bit messy. And if I'm faced with that, I might actually resort to an area model. I know it's maybe not in vogue for some people, but it helps with my organization. And if it helps me, it'll probably help you. So here's what I mean. I really hope I can fit this all in. What I mean is that I have 1, root 3, and minus root 2. Hope that's okay. That minus is a little awkwardly placed. I can't really do anything about it. Well, I could, but it's fine. And then the other one is root 3 minus root 2. This is what I'm multiplying by. Root 3 minus root 2. Now let's see what we get. So this will be root 3. This will be 3. And remember there's a minus there, so this is minus root 6. This right here is minus root 2. This is minus root 6. And this is positive 2. And let's add all this up, and we get 5 minus 2 root 6 minus root 2 plus root 3. Not very pretty. Is there anything else we can do there? No, not really. And that's going to have to be it. It's not very satisfying, but it is correct, and that's ultimately the point. So there we have it. What do you think? Any questions?